Hello, hello. So we will be continuing building our renderer, DirectX12 renderer. I ended up rebooting a bit of the project in terms of getting a new solution and cleaning everything up since I had the IntelliSense problems. It also means that I ended up removing the source folder as an include path um, for the engine project. It didn't really make any sense since all the CPP and header files are in that directory. Um, yeah, so as you can see, I've changed a bit of the settings for the project. Let's see. And I've added a single include for the engine, for the PCH files, and in this project for the game part, we have a linkage to the source of the engine. Yeah, but otherwise everything should basically be the same. Next, we're gonna do a swap chain. To create a swap chain, we need to do several different things. We will create abstractions for the things that we need to create the swap chain afterwards. So a swap chain is a DXGI object. So let's name it as that. Let's look up the interface for the DXGISwapChain. And see which ones we can find. There should be several different ones. Let's see. Usually there are several versions. Yeah. Yeah, there are several ones. Let's see if we a swap chain 1 enhanced capabilities. All right. Let's see. Are there any other versions of the swap chains? It exposes a single method for setting metadata, getting the Index of the current back buffer could be interesting, but lower latency swap chains. Yeah, well, we might as well just go with the swap chain 1 version. It's not really that important to not that really important for now to have any special functionality. So yeah, let's make this inherit from, and look and behold, it really recognizes the namespace declarations and class declarations. That is awesome. So let's say we want to be able to create an empty swap chain. And be able to create a specific swap chain. For now, we know that it will require a 3D12 device, or rather you won't know, but I do. We will just use that for now to discriminate. Oops, I forgot the namespace. IntelliSense is also way faster. I must have messed something up when I set up the project earlier. All right. There we go. So a swap chain as you can see in the documentation, you can create it by calling different methods. There's one where you create the device and swap chain at the same time, but that's DirectX11. We want to create a swap chain with a handle to a window. As you can see, that function takes in a device, a handle to a window, a swap chain description, uh, uh, an optional input of whether it's a full screen description, an optional output device, and the actual swap chain pointer, which will, as per always, be a pointer to our internal pointer of our com pointer. Pointer. All right. So as you can see here, it would take a device, but instead it really takes a Direct3D command queue for DirectX12. That's the difference. So be sure to always read the parameter specifications through. So actually, we won't be using the device for instantiating the actual swap chain, but we will be using the device for something else. Which I will return to later. As you saw, the factory also needs to get passed in. And it was actually the factory that we decided to use that got referenced in the documentation. So we will pass in a pointer to our factory. When we create a swap chain, as you saw, we also needed to get a handle to our window. Our application is the place where we actually start the init method. As we see, we're getting past a handle to the window on the method call of onCreate. If we just pass that into our actual method of our renderer, we will be able to pass it on. Yep. Thereby, we're actually able to pass in the handle. We will add that to our parameters. All right. So far, so good. So now we have not. We actually don't have what corresponds to the device since it's a command queue, but we have the handle and we do not have anything else. So we need to create a swap chain. Yeah, and I've noticed that actually it would be proper practice to implement constant variables. So we will add that to our list of things to do. Add const to parameters where needed. Since we would like to be clear in the future where we change values and where we don't. Okay. Well, so far so good. The last thing we actually need, besides the description, is the command queue. But let's create a swap chain description. In order to create a swap chain description, we need to fill out the structure. It has a width, a height, a format, Uh, uh, um, we have to set the stereo parameter, which I am somewhat unsure what actually covers. We could always dive into um, um, different ways of presetting. This is how the back buffer and the front buffer are flipped during presentation. Yeah, but we'll just run with the parameters which I've been using so far. So I'm gonna move this so that I can type it out more easily, or rather, perhaps I'll keep it here. Let's see. So in terms of our width and height, we will use the Windows structures of the Win32 API to get that. So for our window, we have a client rectangle data structure. I'm pretty sure it's a struct. Yeah, it's a struct. And we will use a Win32 API method called getWindowRect from our handle and pass it into our client rect. That allows us to define the width of the swap chain description as the right corner minus the left corner. We'll also define the height as the bottom minus the top. Next, we define the format. I think that was the next one. Yes. And it has the type DXGI format. We won't mind being able to pass that in. So let's just add that to our parameter list. And pass that in. As I said before, we're just gonna use whatever I used in the past for stereo. We're gonna define the sampling, which is actually a structure. We're just gonna use no sampling and leave a comment. All right. what's up next? So we need to specify what the buffer usage is. Yeah, so as you can see, we can use it as shader input or render target output. A swap chain presents a back buffer to the screen, and the pipeline of the renderer points to outputs to the actual render target. Therefore, our swap chain description is going to be a render target output. Next, we're gonna specify the buffer count. The typical amount of buffers are about 2 to 3. There are different considerations in terms of how many buffers to use. I would like that to be possible to be specified. So let's make an unsigned int that specifies the buffer count. We will let it have the default value of 2. Alright, we pass that in. Next we look up the next parameter. So if we need to resize one of the buffers, or rather, if we have to stretch the output of the pipeline, how would we do it? You could do it like stretch, none, or aspect ratio stretch. Yeah. We don't want to have any scaling. Swap effect is the next one. Let's see. So as you can see, we can't use the first enumeration. We have to use either flip sequential or flip discard. use this flag to specify the flip presentation model and to specify that DXGI persists the content of the back buffer. Let's see. The primary difference between in general, the flipping model is the more efficient model. Yeah. From what I see, we might as well just use the flip sequential. So, swap chain description, swap effect is gonna be flip sequential. Next, we specify the alpha mode. We don't want anything in terms of transparency, so let's just ignore it. DXGI alpha mode ignore. Lastly, we have the swap chain flags. We would like to add the possibility yeah, we would like to be able to switch mode. For now, we will be using windowed mode, but perhaps you want to use full screen and switch it on and off. Let's see, anything else interesting here? So we could allow tearing, but for now we haven't implemented that functionality. So we'll just leave it as a comment. Yeah. And that is almost it. So now we actually just need to create a command queue to be able to create this actual actual component. So let's see, D3D12 command queue. Let's look that up. The command queue is a more complicated structure that we will end up using later on and creating a bit of abstraction around. So for now, we're just gonna use a standard one to create our swap chain. Let's see, create device. What type did we have for that one? Yeah, it's just a basic device. So let's see. Command Q. All right, maybe we can get a pointer to a command queue. Yeah, we can't, of course, create an actual command queue. So on our device, we can call the create command queue, and we need to fill out the command queue description, and we also need to create the pointer to our interface, which we already did. So we will be creating the command queue description beforehand and initialize everything as 0. Let's see. Okay. We're not allowed to do that. Let's see. The first part is yeah, we will be removing this eventually. So first we need a command queue type. And we want the command queue direct since it handles everything. Priority. Let's see. Priority. Global real time. Yeah, let's just create it with the priority of high. flags. We won't be using any flags for this one. And as you can see, we just set the node mask to 0, since we don't have multiple GPUs. Okay. That is one part of our, actually that is the only part of our oh, it's so nice that IntelliSense is actually working. So let's see, we create it by passing in the reference. Let's see. There we go. So now we create a command queue. Let's just see that everything works. Yeah, everything seems to be working. We get no errors. All right. Then we include our swap chain. And let's instantiate it with our device.get factory.get handle to our window and a format. Let's see. Let's see. We want everything float based. So red, green, blue, alpha, 32-bit floating point floating point. Yeah, and we'll just initial start it with the value of 2. Yeah, so we actually aren't creating the actual swap chain, but the method gets called correctly, and so far we have no errors. So we just need to pass in the command queue. So let's do that. Pass in a pointer to the actual command queue. And change the signature. There we go. Now we're able to call create, what's its name? Swap chain description. Describes a swap chain. Swap chain 1 by calling. Yeah. All right. So it's not the command queue, it was the factory. Create swap chain for a window. And as you might recall, for DirectX12, we actually pass in the command queue, not the window. We pass in the handle to our window. We pass in a pointer to our description of our swap chain. And we pass in null, since we don't have any specifiers of input, full screen descriptions or output. And we pass in a pointer to a DXGISwapChain pointer. So that is going to be our compointer's internal pointer. This should return an H result, so let's use our helper function to throw an exception if this doesn't work. Let's see. Neat. Alright, we got an error somewhere. Let's see. No, overloaded. So did I change something? Ah, yes, I forgot to pass in the command queue actually. So we get an exception. And as you can see, our previously initialized debug layer actually prints something now. Or maybe it's the... No, it's supposed to be the... Yeah, so it says that we specified a wrong format. Let's see. Yes. So let's use one of the supported formats instead. You'll have it your way. DirectX12 API. I'm not gonna try to convince you otherwise. So yeah. Now we actually create everything as intended. Maybe we should put that before we actually return so that we can see all live objects. Alright, as you can see, we got a few more live objects by doing that. We create some adapters. We create an output. We create a command queue, swap chain. We also create a command allocator, which follows the swap chain, and yeah. Yeah, but currently we're not getting anything on our screen, and that's because our swap chain is just a component right now, and it doesn't really have any I suppose you could say anything to print to the screen. So in order for it to be able to do something, we need to implement several different things to our swap chain. For it to be created properly and to be able to be handled properly, we will make an integer member variable that stores the buffer count. It will be initialized as 0. We will store the buffer count from our argument list. The thing is that we actually have to create the buffers. These are created preferably when we create the swap chain. They are just basic buffers. In DirectX12, everything is basically a buffer. Just a moment. I'm sorry, I'll have to be right back. All right. So we create the buffers, and we have to, when we use our swap chain, to present whatever gets rendered to the so-called back buffer, the one that isn't in display right now. And we have to also track what the current buffer number is. Yeah. Also, we we want to have actual buffers. In general, we would like to be able to dynamically set the amount of buffers, but we will use the hard-coded version right now, which means that we will have um, 2 buffers. So we have to create our buffers. We will actually make 2 buffers and put them into an array. The buffers will always be a DirectX12 resource. We will get more into that when we start playing around with different buffers, but just for now, note that this is a basic resource type that we a basic resource type that we use for now. So hard-coded for now could be set by global definitions. Perhaps we should, yeah, maybe we should just do it for now. Global settings. Oops, we're not supposed to create a class, just an old habit, delete it, and move this into the source directory. Also delete that. Let's define global number of render frames. Let's put that or specify that as 2. We also want to include our globals. Global settings. There we go. Now we can use this definition as a specifier, and we also want the default value to correspond to that. Okay. When we create resources on our GPU or on our CPU, whichever place we do, we need some information about how they're stored, how they are structured, and DirectX 12 uses so-called descriptor heaps. Descriptor heaps are basically a heap of descriptors. Descriptors are, as I've said, just definitions on how different resources are aligned in memory. This is a lot like how memory is handled on the CPU side. DirectX12 has resources that can be placed either on the CPU or the GPU or a shared space in between them. The agility SDK, which we saw in the last episode, actually is able to create a direct link between the GPU and CPU memory. We won't be using that, but yeah, just a little fun fact. Perhaps the funniest fact you've ever had. So, we will be creating the descriptor heap which will hold our information about our render targets. And let's see, since it's a render target view, we will call this a render target view heap. Lastly, since memory layouts are sometimes hardware specific, we want to store how much space a single resource description takes in the heap, so that we can iterate using pointers over the descriptors and get the proper one by using pointer arithmetics. This is very low level and close to the hardware, but you will see that DirectX12 uses a lot of that methodology to make things work. So we will create another unsigned int that stores our heap increment value. All right. So now we want to create the resources for our render target views. Or rather, I'm sorry, render target view is just a render target description. Or rather, a view is a pointer to a resource. So, yeah, we will start out by creating a descriptor heap that holds our holds our descriptor heap information. We want to create a descriptor heap, as I've mentioned, and we do that using our device. Create descriptor heap, and it takes in a descriptor heap descriptor and where to store it. We already made the com pointer as a member variable, so we of course will have to store it in there. But as you saw, we have to create a descriptor heap descriptor. So let's call it RTV descriptor heap. I'm not sure. Oh, you can't initialize everything as 0. So we will set it manually. Perhaps I can just make it empty. Let's tell the system that we want to create a descriptor heap that is going to hold descriptors of the type render target views. Since the back buffer uses these render target views as, or rather render targets as the actual buffer that holds the content of the pipeline. So the backchain, the swap chain, kind of like it presents the output of the whole graphics pipeline by flipping the buffers so that whatever got rendered to gets passed into the front. And in terms of double buffering, the previous frame that got rendered gets swapped with the back buffer, and therefore is a new back buffer that gets rendered to. And when the pipeline is done rendering to that, you swap again, and so forth. So those resources are called render targets, and the view is just again what is also called a descriptor. So we tell them that this is descriptors for render targets. Next, we have to put in the number of descriptors. We could just use the buffer count, since we will use the amount of buffers that we specify. You can specify flags, but we don't want any flags. You could always look up in the documentation what the flags are, but isn't that correct? Yeah, it was. Okay. But yeah, for now we aren't going too much into that. Perhaps. Yeah, since we don't have multiple GPUs, we don't have a node mask, therefore we specify null. So next we want to actually tell our device that we want to actually create this descriptor heap, as mentioned before. And we will pass in the description, and we will pass in the address of, let's see, that's not the one, the com pointer that we created. to hold our descriptor heap. Now, let's just create the descriptor heap. Describe the render target descriptor heap. And we created the descriptor heap, and now we can specify the increment size of the descriptor heap. So we had a value here that will store how much space the pointers take, and thereby when we increment with the heap increment size, the pointer will be pointing to the next descriptor in this heap. So yeah, we also use the device to get a descriptor handle increment size. As you can see, even IntelliSense knew that I would be probably wanting to call that method. There we go. This returns a uint, this returns an edge result, so let's use our macro to make sure that we actually are able to create the heap. All right. Everything still works as intended. At least we don't get any exceptions or anything like that. Let's see. So now we have initialized a swap chain. All right. So far, so good. Right now, we haven't really done anything though in terms of creating the buffers. So in case we discard the buffers or reset them, this should probably be a separate method. So let's call it create buffers. It won't be taking any arguments, and it will just be let's see if we somehow created we could do an assert in regards to the pointer, so that we don't call our buffers unless our swap chain is properly initialized. Yeah, we could do that. For now, we aren't. Perhaps it's fine. We could do a helper. Yeah, maybe we just say that if the pointer isn't set, we wow, that got misspelled. There we go. Try to create buffers on an empty swap chain. We aren't going to call this very often, so it doesn't matter that we branch a bit. In general, I prefer not to branch too much, especially during functions that are supposed to be somewhat fast. Whoops. Let's see. For each buffer to be expected, we want to create a buffer. In case it is already created, we want to reset it. Since we know that our swap chain is initialized, let's see, swap chain 1, we can start using it. So let's see, what is the method call? If we get our pointer, what methods do we get? We can add a reference, we can get a buffer. So get buffer, get rotation, doesn't really show. So maybe it's on the base object, get buffer, access one of the swap chain's back buffers. A zero-based buffer index. If the swap chain's effect is blah blah blah. So if we chose discard, we would only be specifying 0. A swap effect, the old one, that's I'm not sure. Yeah, so flip is the DirectX12 version. Only the swap chain 0 index buffer can be read from and written to. Yeah, so with our present method, our present method, we are allowed to access several buffers, so we can actually iterate over the back buffers and set them. So this will correspond to I, since we have the flip sequential method swap effect set, which allows us to access all the buffers of the swap chain. So, and as you can see, we need to use the macro, and we will be storing it in our array of com pointers with our resources. So yeah, as you can see, this gets accesses a buffer. Um, since this returns an H result, we want to throw an exception. One of the last things we actually need to do is to create a so-called render target view, meaning that we want to um, link our buffers to let's see. So first we link the buffers to our COM pointers. Then we want to link those resources to our descriptors from our descriptor heap. So to create a render target view, we will have to use the render target view method. Creates a render target view for accessing resource data. Right now we have only created a descriptor heap and specified the actual descriptors in that heap, but we haven't connected the actual description of the resource to the resource. So since we now have an array of resources, we can call this method. It's on the device, so once again you see that well, yeah, we would actually like to store a local pointer to our device, or perhaps pass in the pointer itself when we call the method. I think it's way easier just to store it. So we will store it on the object. Once we're done, everything should be fine. Just copy the actual pointer. Yeah, then we can use the device to create our render target view. as you see, we have to pass in the actual resource, or rather the pointer to the resource. We also need to, or at least we can, optional, yeah. So at least one of them. So if we specify one, we can pass in null as the other one. So we get a default descriptor. Not all resources support null descriptors, but let's just try it out. And we have to pass in a CPU descriptor handle. So this is for the CPU side, where to find the descriptor handle. So as you can see, where we put the newly created render target view. CPU handle. And our object of the render target heap actually has a method that allows us to get the CPU descriptor handle for the start of the heap. So this can track where the descriptor heap is placed in CPU memory. And let's see. This structure also has a pointer. I actually think it's the only. Yeah. So the pointer gets initialized to the start of the heap, but we want to let's see what is the type. The type is size t. So we want to increment the pointer as we go along the methods. So for each buffer, we want to pick out the next one. So if there's 2 buffers, we first get the first one. I will be 0, so therefore we don't increment. Next, we're gonna increment by the size of each descriptor. And then we simply just pass in the descriptor handle. And this is a void function, so it doesn't really do anything. All right. Now we can actually create the buffers when we are done with our swap chain. Let's see. Yeah, we changed the name of that one. Let's see. All right. In case we want to drop the buffers, we create a method for that. In terms of if we need to reset the swap chain, it's usually useful to drop the buffers and recreate them with the new settings. So we will simply do the same code here. Next, we want to implement if these are related to construction, we want to have a method called present, which is actually the main function of our swap chain. Of course, we should only use this if our swap chain is valid. I'm not gonna put in a branch where we have to check whether something is set or not inside the actual present method, but do be mindful of how you implement this method, as you might get access violations. So the actual swap chain has a present method, which will take 2 flags, the sync interval, and the flags. Let's just look them up. I'm just typing in. Let's see. So we use this method, cancel the remaining time on the previous presented frame, and discard this frame if a newer frame is queued. And you can synchronize yeah, we can implement allow tearing support in the future. But yeah, so when we present, we want to increase our current buffer index, since the present function will flip the back buffer and the other buffer. So therefore we always want to clamp it between the buffer count. Yeah, so for triple buffering, this is allowed to be 0, 1, 2, 1 and 2. For double buffering, we're only allowed to have 0 and 1. All right. Now that we are able to present our back buffer, we are somewhat close to our goal. But since this is a complicated object that stores different what should we call it? Different. It stores different resources that are all reference counted, and something that needs to be reset in case we allow the objects to get additional references whenever the swap chain gets destroyed. We want to make sure that our resources get released. So for that, we will create an actual release function and a destructor. Let's see, did it create them both? Yeah, let's just call release manually. And of course we will be dropping the buffers. Then we will be resetting our resources. So since we use drop buffers to release the, or at least reset the pointers inside as our drop buffers method. So internal release sets the reference count to 0. And releases the internal object. So we want to do that, but we also created a descriptor heap, which means that we want to reset that. And when we're done with that, we could reset the current actually I think that since we are able to call release, we want the swap chain to drop its content as well. So by calling the compointer method reset, we also actually release the actual swap chain object. Yeah. All right. Yeah. I'm pretty sure our swap chain won't allow us to present just yet. Let's see. Oops. Yeah. 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 When we do that, we end up getting synchronization errors, it seems. It's also because this is not a initialization call. It's rather a it's for the render loop. So whenever these objects go out of scope, if we have passed on a present to the command queue, yeah, object life cycles won't be properly managed, and we get serious errors. So yeah, but that is basically it for our swap chain so far. Now we need to do a bit of housework. We need to check whether our methods use const where appropriate. So the debug methods do not take any arguments. So we can close those. But yeah, this one takes a pointer that shouldn't change. Therefore, we should, and we can comment that out for so that we don't get a warning. There we go. We don't want that to be unclear. Let's see the factory. We don't have any arguments there as well. So just close that. The swap chain is actually, the pointer itself won't change. Therefore, we add const to these. There we go. Let's just add it to our signature. All right. Seems like we're not allowed to specify that as const. All right. It must be changing some of the underlying information. Huh? Okay. We also need to change that. Can't be constant, apparently. All right. So those methods can't promise that they don't change the underlying. Yeah, it's the same here. All right. Turns out I wasn't being sloppy. This should be constant though, right? This should be constant. I'm pretty sure. Let's see. How did we end up creating an error? DXGI adapter. There we go. It can't compile whenever we do that. Okay. Yes. So no const for us. That is it for our swap chain for now. The next thing we will do is probably a bit of structuring around our command queues and command lists. since we're getting to that point where we actually might render something to our screen in the nearby future. Yeah, so I think that's our next steps. Those are our next steps. Yeah. Let me see whether that is correct. Yeah, I think so. I think so. Great. Yeah, I think so. Yeah, it seems like that command queues and command lists are our next logical step. So yeah, I'll be seeing you in the next one. Hopefully you enjoyed some of this content. If you did, feel free to like, comment, subscribe, follow, or whatever.